In the last lesson, we finished on a graphical representation of what you see on a balloon pump console monitor. Here's what that monitor looks like in real life. At the top, in green, is the ECG tracing. This patient has a heart rate of 80 beats per minute and is in normal sinus rhythm. Next, in red, is the intra-aortic pressure, measured from the balloon pump catheter. You can see the waveform corresponds to the tracings we saw in the last lesson, with systole, followed by augmented diastole. The console also displays the systolic, diastolic, and mean pressures in numeric form, again measured from the balloon pump catheter itself. Finally, in blue, we see the pressure waveform of inflation and deflation of the balloon. You'll notice that the balloon pump is inflating with every cardiac cycle, a setting we call 1-to-1 inflation. The augmentation number shown in white is the pressure to which the balloon is inflating. This is the highest pressure we should see and represents the increased early diastolic blood pressure when the balloon is inflated. Okay, let's pause for a quick quiz to see if you're tracking so far. On this balloon pump console, can you locate systole and diastole on the aortic pressure tracing? Take a moment to pause the video and give it a try. Since this tracing shows the balloon pump inflating with every cardiac cycle, the systolic pressure curve is the smaller peak, followed by the augmented diastolic pressure curve, the higher and broader peak. Now, what is the augmented pressure and what does it mean? Take another moment to pause the video and give it a go. The augmented pressure is 116 millimeters of mercury, corresponding to the pressure inside the balloon and the peak early diastolic pressure. Now that you've mastered 1-to-1, here's a curveball. This aortic pressure tracing shows the balloon pump set at 1-to-2 mode, meaning it is only inflating every second cardiac cycle. On the tracing, these bolded segments correspond to a cycle with the balloon inflating, and these thin segments represent a normal cycle without balloon inflation. Easier than you thought, right? Now, we have to think about the terms assisted and unassisted. Assisted refers to a pressure that's been helped by the balloon pump, and unassisted represents the patient's own hemodynamics without any help. So, pause the video for a moment and identify which spot on this tracing would represent the assisted end diastolic pressure. That's right. The lowest point on the bold curve shows the end diastolic pressure as the balloon deflates in pre-systole. Now, what about the unassisted end diastolic pressure? Well, that's just the end of the narrower unassisted curve. Systole is trickier. The assisted systole actually occurs right after the balloon deflates, so it's during this thinner curve when the balloon is not doing anything. And that means unassisted systole is actually this peak here. As you remember, the balloon will still be deflated during systole and only inflates during diastole. A few important things to notice. Assisted systolic pressure is lower than unassisted. This is because the assisted end diastolic pressure is lower than the unassisted end diastolic pressure. Since the end diastolic pressure is the start of the systolic pressure, you are starting from a lower point. Therefore, the peak systolic pressure generated is lower. This results in decreased afterload, one of the key effects of the balloon pump. The peak diastolic pressure is the only one that increases with assistance, as we remember that the balloon inflation causes diastolic augmentation here. There is no such augmentation on the cycles without balloon inflation. But, and this is important to remember, the numeric reporting of diastolic blood pressure on the console shows the end diastolic pressure rather than the peak diastolic pressure, so it is the lower number. This means that when looking at the numeric display, like in this example, where both assisted and unassisted pressures are shown, the assisted systolic blood pressure, or SBP, and the assisted diastolic blood pressure, or DBP, will both be lower than unassisted. The mean arterial pressure, or MAP, however, will usually be higher with the balloon pump because of the increased early diastolic pressure. When using a balloon pump in a clinical setting, it can be very difficult to see the subtle differences in assisted and unassisted pressures in the 1 to 2 mode. So, we often put the pump in standby mode to see unassisted hemodynamics and compare that to when the balloon pump is in 1 to 1 mode. So, let's predict what would happen if you turned the balloon pump into standby mode, a great way for you to check your knowledge. The augmented pressure becomes 0. Compared to 1 to 1 mode, the systolic blood pressure will rise, the diastolic blood pressure will rise, the MAP will decrease, and the aortic pressure tracing will not show any early diastolic augmentation. The goal of a balloon pump is to see a 10% reduction in SBP and end DBP, a MAP that stays the same or rises, and the augmented pressure should be the highest pressure on the console. Phew! Great work sticking with this lesson. You know more than most about how to interpret the balloon pump monitor. Next, let's learn some practical day-to-day management strategies.